When you plot data on a graph and adjust it so it fits a straight line, you're actually using the mathematical model y equals mx plus b. And what you can learn from this graph is basically the slope of the line of best fit m and the intercept of that line through the y-axis b. And they should tell you something about the experimental results you're trying to determine. Now, in the second part of this exercise, you're going to be reanalyzing your data from Practical 2, and you're going to be using the mathematical model length of a pendulum equals g times t squared over 4 pi squared. And you're going to calculate values of period squared over 4 pi squared, and you're going to graph that calculated value against the L. The length of the pendulum needs to be on the y-axis, and this calculated value needs to be on the x-axis. Now, there is no plus b there. There's effectively plus 0, and that means we expect this graph to go through the origin. So, firstly, you need to choose a scale for your x-axis, which uses a reasonable distance along your graph paper. And if we set 0 there, you may find that the point 0.1 is a typical maximum value of that for the data you have. That goes from 0, and along that x-axis is the calculated value t squared over 4 pi squared. And then up the y-axis you plot L. We worked with pendula that were up to 1 metre long, so you'll need a y-axis that goes up about 1 metre. And again, let's just choose a distance 1.0 there, 0 there, and that'll be your length in metres. Now hopefully when you plot your data, you will get a series of data points along here. You'll then plot the error bars on them, and hopefully when you draw your line of best fit, you will get a straight line which you expect to pass through the origin. If that does not pass through the origin, in other words, if there is a small correction there, it could mean in your original experiment you had a 0 error in your measurements of length. To determine the value of g, you need to measure the slope of this graph. Now, you don't just choose 2 arbitrary data points, you need to measure the slope of the line of best fit itself. And the slope of the line is basically the rise up the y over the horizontal run. And you need to use the units along the axis. And so if we've gone out to about 0.1 here, then this would be about 0.1. Over here you would have to look down there and see what that distance is, and you actually have to work out what is that distance there. I'll just call it delta x. Likewise, for the vertical rise, you have to read across to the axis and get the actual value from the axis there and the value from the axis there, work out the difference between them and work out your rise. And your slope m of course is delta y over delta x, rise over run. In this case it'll be that distance over that distance measured in terms of the scales on the graph.